Hello students, in this video we are going to go through Chapter 1, Introduction to Statistics, Section 1, Statistical and Critical Thinking. So the key concept here is the process involved in conducting a statistical study consists of prepare, analyze, and conclude. So statistical thinking involves critical thinking and the ability to make sense of results. Statistical thinking demands so much more than the ability to execute complicated calculations. Again, it's not just about number crunching, it's more about thinking critically and looking at it from different angles. So when we talk about data, what is data? Well, data is just the collection of observations, such as measurements, genders, survey responses. Pretty much any information that you have is what we will call as data. Statistics is the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions about them. So pretty much you collect your data from various sources, and then we look at that data to make conclusions from it, whether that be saying a certain drug is effective because the stats show that more people are cured of their disease, or more people are going to likely vote for this one candidate. It could be anything. When we talk about population, the complete collection of all measurements or data that is being considered. A population is the complete collection of data that we would like to make inferences about. So, for example, when we talk about population, it might be the entire population of the United States. It could be every male in New Jersey. It could be every female at Middlesex Community College. It's talking about the entire group as a whole. Whereas a sample is a sub-collection of members from a population. If you want to know who is likely going to win an election, it's unreasonable to do a poll that includes every single person of the population. That's obviously what they do on election day. So what they do is they do a sample. So they do a sub-collection, meaning that they interview or survey or just talk to a small group of people, and then they make conclusions about the entire population from the data collected through that sample. A census is the collection of data from every member of a population. Think about when you do populations numbers, how many people are in the population. You collect data from every single member of a population. Now, that's usually unrealistic and it's just not feasible. So that's why typically we are using samples. So samples are a subgroup of the overall population. The population is everyone as a whole. So example, residential carbon monoxide detectors. In the journal article, blah, 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 it was stated that there are 38 million carbon monoxide detectors installed in the US. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So in this case, let's look at what the population and the sample are. So the population is going to be every carbon monoxide detector in the United States. The sample is what we're actually going to be sampling. It's the 30 carbon monoxide detectors that were actually selected and tested and analyzed. So the objective is to use the sample data as a basis for drawing the conclusion about the population of all carbon monoxides. It's clearly unreasonable and unrealistic to analyze 38 million carbon monoxide detectors, but you can analyze 30 of them, and then you can use that 30 to make a conclusion about the overall population. So we're using the sample to make conclusions about the population. Here's a little flow chart that just talks about how we're going to prepare our questions and prepare how we're going to collect the data, collecting the data, analyzing the data, and then making conclusions based on that. So talking about different ways to collect data. One is a voluntary response sample. So again, we're talking about different ways that data can be collected. And this is voluntary response or self-selected sample is one in which the respondents themselves decide whether to be included. So it has inherent biases because it's voluntary. People can choose to talk about it or not talk about it. So they are seriously flawed because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. So internet polls are a form of voluntary response sample in which people online decide whether to respond. Mail-in polls are voluntary response. Telephone call-in polls, newspaper, radio, etc. Anything where you are being probed to voluntarily respond to a certain opinion. So here is an example. So Nightline asks viewers to call with their opinion about whether the UN headquarters should remain in the US. Viewers then decided themselves whether to call with their opinions, and 67% of the 186,000 respondents said that the UN should be moved out of the United States. A separate study, completely independent of the Nightline call-in poll, said that out of 500 respondents, 38% of the group wanted the UN to move out of the US. So those are drastically different results. So which one is reliable? Well, even though the Nightline poll involved many more people, these people were volunteer respondents. Whereas this group right here, the smaller group of 500, they were randomly selected. And that's what we really want. The randomly selected respondents is more likely to provide better results since it's a better sampling method. Randomly selected means that I'm not cherry picking people, or I'm not setting up a way for people with stronger opinions are more likely to respond, etc. I'm getting a more true data sample. So from here, we can now analyze. So after completing our preparation by considering the context, source, and sampling method, we can now analyze the data. And that's kind of making sense of the information we gathered from our sampling method. So we could graph and explore it. We're going to put our information in a form, kind of like a visual form, like a graph, a bar chart, a pie chart, anything like that. And then we can apply statistical methods. And this is not rocket science here. You're just putting things on a graph, and then you're making conclusions based on it. So just common sense will get you a long way in this class. So once we got our sample, we analyzed it, now we make conclusions. So we are going to see if it's statistically significant. And generally, we are saying that statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. That number will come up play a lot, well, not a lot, but in a chapter or so later, but just kind of put that in your back pocket for now. So getting 98 girls in 100 random births is pretty significant because that wouldn't happen from random chance. However, getting 52 girls in 100 is not statistically significant because that event could easily occur with random chance. And then there's practical significance. And it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or practical. So what you're saying is that it might be mathematically significant, but in practice, it doesn't really matter too much. So ProCare Industries once created a product that would apparently increase your chances of having a baby with the gender that they desired. So suppose that the product was tested with 10,000 couples who wanted to have baby girls, and then the result consisted of those 10,000, 5,200 baby girls were born out of that 10,000. Now you would say that the amount of births should be around 5,000 being girls, half of the total population. So this result of 5,200 is statistically significant because the likelihood of it happening due to chance is only 0.003. So chance doesn't seem like a feasible explanation. However, you would say that 52% is kind of only barely above half. So in practical sense, that's not really significant. So you would say, okay, thanks, but no thanks. I'm not paying a lot of money to only increase my chances by 2%. So that's talking about statistical significance versus practical. Okay, the next topic is analyzing data and potential pitfalls. And here is where we're talking about biases and just ways that we're getting data that can't really be trusted. We might have misleading conclusions. So when forming a conclusion based on an analysis, we should make statements that are clear even to those who have no understanding of stats and its terminology. Avoid making statements not justified by the analysis. And remember that correlation does not imply causation. Bold, highlight, underline, drill this into your head that just because two events happen simultaneously does not mean that one is causing the other. Correlation is only the first state in proving a causal relationship. So another method to avoid potential pitfalls is sample data reported instead of measured. Basically, it's better to take measurements yourself than having people self-report their own data. People lie to answer the question in a way that they think or want you or think that you should respond. For example, maybe you're asking people, hey, what's your weight? Okay, maybe people are going to lie about their weight. Maybe some women might not feel comfortable about sharing their weight in person, so they're going to lie about it, and now you have false data. Maybe some men might lie about their heights on online dating to figure women like taller men. If you self-report, you're going to likely have problems. If you measure it, you're going to get rid of the problem that people might lie or round or just not be fully transparent. Another potential pitfall is loaded questions. So if survey results are not worded carefully, the results of a study can be misleading. So they might word a question in a certain way that will kind of elicit a desired response. And the last slide of this PowerPoint, continuing with potential pitfalls, is order of questions. So sometimes survey questions are unintentionally loaded by the order. So yes and no questions, which build upon the previous one, can kind of lead the witness to answer in a certain way. Non-response occurs when someone either refuses to respond or is unavailable. People who refuse to talk to pollster have a view of the world around them that is different from those who will talk to the pollster. So basically, if you ignore the people who don't respond, you might be ignoring an entire population of people, so those that do respond are going to be overrepresented in the actual data analysis. And then finally, percentages. So some studies cite misleading percentages. Note that 100% of some quantity is that all of it, but if there are references made to percentages that are exceed 100%, they are not justifiable. And this will make sense when we're looking at chapter 2 and 3, where people might have redundant answers or things might overlap, and then the overall quantity of those interviewed exceeds 100% or is under 100%. And you kind of got to look at that and scratch your head a little bit if the total number of people is not exactly 100% if you round everyone and add them all together. All right, thank you.